There is a country in the North Atlantic where the ground is pulling apart. Not metaphorically, literally. Iceland sits directly on top of the mid-Atlantic ridge, the boundary where two tectonic plates are separating at roughly the speed your fingernails grow. And the result is not some quiet geological footnote buried underground. It is visible. You can drive past lava fields that did not exist 3 years ago. Some of this rock is so new it has not yet been named. That dark terrain stretching toward the ocean is the Reykjanes Peninsula. The lava you are looking at cooled within the last few years. The land beneath it is among the youngest on Earth, shaped by recent volcanic activity and still visibly raw. Now look at where this peninsula sits, extending into the surrounding water and shaping everything around it. Iceland is the only place on Earth where the mid-Atlantic ridge, the longest mountain chain on the planet, rises above the ocean as an inhabited country. This ridge runs for roughly 16,000 kilometers along the Atlantic floor, but almost all of it is hidden beneath thousands of meters of water. Iceland is the exception, where glaciers and volcanoes share the same stark landscape, often side by side. Here the ridge breaks the surface and the crack it creates is not abstract. At Þingvellir, roughly 45 minutes from the capital, you can walk into a valley and see the boundary between the North American plate and the Eurasian plate. The rock walls on either side begin to move farther apart and the narrow passage starts to open up. The gap is filled with some of the clearest water on the continent, filtered through porous lava for decades before it surfaces. But what makes Iceland remarkable is not just that the rift is visible, it is what happens less than an hour from here. Reykjavik, the capital, is a modern European city of roughly 140,000 people. Its streets are warm in winter. Not because of expensive gas heating, because the same tectonic forces pulling the island apart also push heat toward the surface. Nearly every building in the greater Reykjavik area is warmed by geothermal water pumped directly from underground. The same process that cracks open fissures and sends lava across highways also heats homes, fills public swimming pools, and powers greenhouses that grow tomatoes and cucumbers in long, glowing rows near the Arctic Circle. Consider the numbers. Iceland has roughly 30 active volcanic systems. The country records tens of thousands of earthquakes every year. Many are too small to notice, but some hit hard enough to crack pavement, buckle sidewalks, and shift entire roads. And yet, this is also one of the safest, most stable, highest trust societies on the planet. Roughly 400,000 people live here. They run a full modern economy, a universal healthcare system, a parliament that traces its roots back over 1,000 years. All of it sits on ground that is measurably, physically still being made, with fresh layers of earth and rock building up beneath it. This is not a country sitting on top of danger. It is a country that turned its geology into infrastructure. The rift explains why Iceland exists, but it does not explain how people live with what comes out of it. In late 2023, the ground southwest of Reykjavik split open. Orange lava poured across the Reykjanes Peninsula, close enough to a town that the glow was visible from bedroom windows. This was not a remote highland event. It was happening next to roads, power lines, and the international airport. The town of Grindavik, home to roughly 3,700 people, was evacuated. not because lava reached the houses immediately, but because the ground beneath the town was deforming. Cracks appeared in streets, foundations shifted, and the seismic data showed that magma was moving underground in a way that could not be predicted with a clean timeline. What made this different from a single eruption was the pattern. Reykjanes had been volcanically quiet for roughly 800 years. Then came the eruptions near Fagradalsfjall, and by 2023 they were edging closer to roads and people. And closer together. Look at a map of the Reykjanes Peninsula, where southwest Iceland narrows toward the Atlantic. The fault lines run directly beneath the road connecting Reykjavik to Keflavik International Airport, Iceland's only major gateway to the outside world. Eruption sites dot the terrain within just a few kilometres of the highway, scattered across the dark volcanic ground. And sitting right in the middle of this volcanic zone is one of the most visited attractions in the country. The Blue Lagoon, famous worldwide as a luxury geothermal spa, was forced to close repeatedly because of nearby volcanic activity. Visitors book months in advance to soak in milky blue water surrounded by lava rock. Most of them do not realise the spa sits on an active volcanic system, or that the water itself originates as runoff from a geothermal power plant. But Iceland does not respond to eruptions with panic. It responds with data, tracking tremors, gas and lava as events unfold. The Icelandic Meteorological Office operates a dense network of seismometers, GPS stations and gas sensors spread across the country. When magma moves underground, the instruments detect it, sometimes days or weeks before an eruption. Scientists interpret the data. Civil protection authorities decide when to evacuate, when to close roads, and when to reopen them. This is not a country that waits for disaster and reacts. It is a country that monitors, communicates, and trusts the process. Residents of Grindavik followed evacuation orders calmly. Public updates came frequently and plainly, and when the situation changed, decisions changed with it. The deeper question is not about one eruption, it is about a cycle. Geologists suggest that Reykjanes may have entered a period of recurring volcanic activity that could last years, possibly decades. If that is the case, Iceland cannot simply rebuild and forget. It has to plan roads, housing, energy infrastructure and tourism around a landscape that may keep changing. For a country of roughly 400,000 people, that is not a hypothetical problem. It is a planning reality that shapes budgets, construction codes, and national confidence. Reykjanes shows what happens when fire breaks through, but most of the time Iceland's volcanic heat stays underground, where it becomes something entirely different. Nearly every home in Reykjavik is heated by the same volcanic force that just threatened a town an hour away. Drive less than an hour from the lava fields on Reykjanes, and you reach a capital where steam drifts from rooftops on winter mornings. Not from chimneys, but from the ground itself, captured underground and piped beneath the city through buried tunnels. Roughly 90% of Icelandic homes are heated by geothermal energy, with hot water piped in from the volcanic ground below. In Reykjavik, hot water is pumped from boreholes deep underground and distributed through a network of pipes to every neighbourhood. The water arrives at taps so hot that residents often need to mix in cold water before using it. And here is something most visitors never notice. Some of Reykjavik's sidewalks and downtown parking areas are heated by hot water running through pipes just beneath the surface. In winter, while other Nordic capitals clear ice and spread salt, sections of Reykjavik stay bare and dry. The infrastructure is invisible. You walk over it without knowing. But the warmth is not just in the pipes. Icelanders have built an entire social ritual around geothermal heat. Across the country, there are more than 170 public swimming pools and hot pots, most of them outdoors and heated by the earth. These are not tourist attractions, they are where Icelanders go before work after school on weekends. Neighbours catch up in chest-deep water while snow falls around them. The pool is Iceland's version of the town square. And the same heat reaches even further. In greenhouses scattered across the southwest, geothermal energy allows farmers to grow tomatoes, cucumbers, peppers, and herbs year-round in long greenhouse rows just below the Arctic Circle, where the growing season outside is far shorter. Artificial lighting extends the short winter days, but the heat itself comes free from the ground. Iceland imports far less fresh produce than most people assume. Now consider one of Iceland's most famous attractions. The Blue Lagoon looks like a natural hot spring and it is marketed as a luxury wellness experience. But the milky blue water is actually runoff. It originates from the Surtsey geothermal power plant, which pumps superheated water from deep underground to generate electricity. The mineral-rich wastewater, too silica-heavy to return to the aquifer, pools on the surface. Someone realised it felt extraordinary to bathe in, and an industry was born. The luxury brand grew from an industrial byproduct. Zoom out and the pattern becomes national. Iceland generates nearly 100% of its electricity from renewable sources, split between geothermal and hydropower. Heating costs for residents are a fraction of what Europeans pay for gas or oil, and that cheap, abundant energy has attracted an unexpected industry: data centres. Server farms run by international companies now consume more electricity in Iceland than all Icelandic homes combined, drawn by renewable power and natural cooling. Even Reykjavik's most recognisable building tells the same story. Hallgrímskirkja, the church that dominates the skyline, was designed with a facade inspired by basalt column formations. The same hexagonal rock created when lava cools rapidly. The geology did not just warm the city, it shaped its architecture. Reykjavik turned volcanic heat into comfort, but Iceland's relationship with that heat goes far beyond the capital. The world's oldest surviving parliament was not built inside a palace. It was founded inside a crack between two continents. Around 930 CE, Norse settlers gathered at Þingvellir, a valley where the North American and Eurasian tectonic plates pull apart. They did not choose this place by accident. The Rift Valley created natural rock walls, and those walls did something extraordinary. They amplified the human voice. A speaker on the rock outcrop called the Lögberg could project to hundreds without shouting. The geology served as architecture. This was the Althingi, and for centuries Icelanders returned every summer to settle disputes and make law. Today the rift is still widening. The same boundary that created a gathering place is still pulling apart at roughly 2 centimetres per year. The institution outlasted the geology that made it convenient. Now consider what this means for national identity. The settlers brought Old Norse, and because Iceland was isolated by ocean, that language was never overwritten by continental shifts. Icelandic today remains so close to Old Norse that schoolchildren can read sagas written 800 years ago with only modest help. No other Scandinavian country can make that claim. The language survived because the island kept the world at a distance. But isolation also forced adaptation. There were almost no trees. Settlers built turf houses, layering stone and earth into walls that could withstand Atlantic winters. They brought horses, and those horses have remained genetically isolated for roughly 1,000 years. Once an Icelandic horse leaves the island, it can never return. The sagas, the parliament, the language, the horses, none of these are museum curiosities. They are still part of how Icelanders understand themselves. And the foundation of all of it sits inside a rift valley that the planet is still pulling apart. The rift gave Iceland its identity, but the island's other defining force, ice, is telling a very different story. For the first half of this film, Iceland has been a story of fire, the rift that splits the island. The lava that threatens nearby towns also heats homes, flowing from the volcano into the landscape around them. But Iceland has a second defining force, and it is moving in the opposite direction. The glaciers that cover roughly 8% of the island are not growing. They are retreating. And the most photographed ice in the country exists precisely because the largest glacier in Europe is losing ground. Vatnajökull covers roughly 7,700 square kilometres of southeast Iceland. From above, it looks like a white continent pressed onto a volcanic island. It is so large that it contains its own weather systems, and it hides something underneath. Beneath the ice sit several active volcanic systems, including Grímsvötn and Bardarbunga. When one of these volcanoes erupts under the glacier, the heat melts enormous volumes of ice from below. The meltwater builds until it bursts free in a catastrophic flood called a Jökulsárlón. These floods can destroy bridges and close the ring road within hours. Iceland has had to engineer its infrastructure around the knowledge that the rivers fed by this glacier can change volume without warning. But Vatnajökull is not just a source of risk, it is also the source of one of the most famous landscapes on Earth. Jökulsárlón is a glacial lagoon in southeast Iceland that did not even exist a century ago. It formed because the outlet glacier has been retreating, leaving behind a deepening basin that filled with meltwater. The blue icebergs drifting across the lagoon are pieces of a glacier that calved because it is shrinking. The lagoon itself is growing larger decade by decade. What most visitors experience as serene beauty is, measured over time, evidence of accelerating loss. And then the icebergs drift out to sea and wash back onto the shore. Diamond Beach is one of Iceland's most photographed places, where clear chunks of glacier ice wash up across the black sand. Every piece of ice on that beach was once part of a glacier that took centuries to form. None of it is coming back. Inside Vatnajökull, another phenomenon draws visitors each winter. Ice caves form where meltwater carves tunnels beneath the glacier. Their blue walls glow with compressed light, but these caves are temporary. They shift, collapse, and reform each season. The cave a visitor photographs in January may not exist by March. The beauty is inseparable from the impermanence. Not every glacier in Iceland has the size to survive. In the Western Highlands, a glacier called Okjökull was declared dead around 2014. When it lost enough mass to stop moving under its own weight. In 2019, a memorial plaque was placed on the bare rock where the glacier once sat. It was addressed to the future. Okjökull was the first Icelandic glacier to receive a formal farewell. It will not be the last. Ice shaped Iceland's interior, but the coast shaped everything else. Livelihood, danger, isolation, and identity. The most photographed beach in Iceland is also one of the most dangerous places on the island. Reykjanes looks extraordinary. Black sand stretches toward basalt sea stacks rising from the Atlantic. Hexagonal columns line the cliff face like the pipes of a geological organ. Visitors walk to the edge of the water. And that is where the problem begins. Just beyond the shoreline, the beach drops steeply into the ocean, leaving little shallow water near the edge. When swells hit that gradient, they do not roll in gradually, they surge. A wave that looks small offshore can rush dozens of meters up the sand in seconds. These are called sneaker waves, and at Reykjanes they are not a freak event. They are a structural feature of the coastline. Multiple visitors have been killed or seriously injured here. Warning signs stand at every access point. But there are no fences, no barriers, no lifeguard stations. This is an open volcanic coast. Managing it means convincing people that beauty and danger can occupy exactly the same space. The black sand itself is a volcanic product. When basalt lava meets cold seawater, it shatters into fine dark grains. The columns formed as thicker flows cooled slowly, contracting into hexagonal shapes, a process that looks engineered but is purely physics. The sea stacks offshore are remnants of older basalt cliffs the ocean has eroded down to towers. This entire coastline was built by eruptions meeting the Atlantic, and it is still being reshaped by the same collision. But the coast is not only a spectacle, it is also a workplace, where boats launch, nets are hauled in, and the shoreline shapes daily life. Along the south coast, small fishing villages sit in harbours carved between cliffs. The Atlantic is both livelihood and threat. Weather can shift in minutes. Boats go out when conditions allow and stay docked when they do not. For generations, the rhythm of these communities has been set less by calendars than by wind, swell, and visibility. And inland from the coast, Iceland's famous waterfalls offer another clue to how the coastline was built. Skogafoss stands at what was once the edge of the sea. Volcanic deposits gradually extended the land southward. The waterfall now sits several kilometres inland, but its position marks an older Atlantic shore. The coast feeds, threatens and defines Iceland, but beyond the famous south coast there is an Iceland most tourists never reach. The coast feeds, threatens and defines Iceland, but beyond the famous south coast there is an Iceland most tourists never reach. Most visitors to Iceland stay within the southwest corner, the Golden Circle, the south coast, Reykjavik, and the Blue Lagoon sit inside a small loop that covers less than a fifth of the island, a compact stretch where several of Camino's best-known sites are clustered close together. Everything else, the Westfjords, the Eastfjords, the north, is home to the people who live here year-round, and what defines their daily life is not volcanoes or glaciers. It is shaped by the weather, the long distances, and the roads that connect one place to the next. The Westfjords are a jagged peninsula in the northwest, cut by deep fjords and connected to the rest of Iceland by a single narrow neck of land. Some communities here are closer by boat to Greenland than by road to Reykjavik. In winter, mountain passes close for days. The tunnels connecting fjords are sometimes single lane, requiring drivers to pull into passing bays when headlights appear ahead. Isolation is not a metaphor here. This is simply a look at the road condition, with the texture of the surface and the signs of wear clearly visible across the pavement. In these small harbours, fishing is not heritage tourism, it is the economy. Boats leave before dawn. The catch determines the season. Families know the weather not from forecasts but from generations of watching the same fjord. Community trust is not an abstract value. When the road closes, the town becomes the whole world, with everyone focused on the same few streets and storefronts. To the east, the landscape changes. The East Fjords hold some of Iceland's oldest rock, formations over 10 million years old, compared to the fresh lava in the west that may be only a few years old. There are no active volcanoes here. The mountains are rounder, the fjords quieter. It is the part of Iceland that looks least like the Iceland visitors imagine. And yet people have lived here for centuries, building harbours in every narrow inlet where the mountains allowed it. What connects these remote edges is not geology but light. In midsummer, the Westfjords experience near-continuous daylight. The sun barely dips below the horizon before climbing again. Sleep patterns shift, work stretches, children play outside at midnight, and in December, the same latitudes receive only 3 or 4 hours of functional daylight. The rest is a long blue twilight that shapes mood, routine, and the rhythm of an entire community. This is Iceland without an audience. No tour buses reach most Westfjords harbours. No postcards feature the East Fjords hills. The roads here are not scenic routes designed for visitors. They are supply lines, school routes, and emergency corridors maintained by a country of roughly 400,000 people across an island the size of Kentucky. Remote Iceland shows how the country works without tourism, but the places tourists do reach are facing a different kind of pressure. The beauty Iceland is famous for may be too fragile to survive the attention it attracts. Look at this lava field. Centuries of wind, rain and patience turned raw volcanic rock into a soft green carpet of moss. Some of these patches have been growing for over 100 years, but step off the mark trail just once and the damage is immediate. A single footprint can crush moss that took decades to form, and the scar can last just as long. Roughly 2 million visitors arrive each year. The population of the country is around 400,000. That means there are roughly 5 tourists for every resident during peak season, and many of those visitors are drawn to the same handful of fragile sites. Fjadraglúfa Canyon is a case study in what happens when attention arrives faster than infrastructure. This narrow gorge in southern Iceland became globally famous after appearing in a music video. Visitor numbers surged. The paths eroded. The vegetation along the canyon rim began to disappear. Authorities temporarily closed the site. Not because it was dangerous, but because the landscape itself was being loved to death. Across Iceland, the response has been a quiet national negotiation between access and protection. Boardwalks now line routes through delicate lava fields. Rope barriers mark the edges of moss zones. Popular canyons and waterfalls have timed closures. Some highland roads simply do not open until the ground is dry enough to survive tyre tracks. But conservation is only one part of the pressure. The people who absorb the daily risk of tourism are often volunteers. Iceland's search and rescue teams are overwhelmingly staffed by unpaid locals who respond when visitors underestimate distances, weather, river crossings, or coastal waves. In a country this small, every rescue pulls from the same thin layer of community trust. Back in Reykjavik, the pressure takes a different form. Short-term tourist rentals have reshaped the housing market. Apartments that once housed local residents now cycle through a steady stream of international guests, with suitcases rolling through the same hallways. For a capital of roughly 140,000 people, even a modest shift in housing supply changes what locals can afford. Iceland is not closing its doors. But it is learning, site by site and season by season, that the landscapes drawing global attention were shaped by forces that move far slower than a booking confirmation. Tourism pressure is just one way Iceland's landscape is changing, but offshore, the island is telling a deeper story about creation and loss. In 1963, an island rose from the ocean south of Iceland. Fishermen saw columns of smoke and ash breaking through the surface of the Atlantic near the Westman Islands. Within days, a new landmass was forming. They named it Surtsey, after the fire giant of Norse mythology. And then they made a decision that would turn this raw volcanic rock into one of the most important scientific sites on Earth. They kept almost everyone away. Access to Surtsey was restricted to a small number of researchers each year. No tourists, no settlers, no interference. The first seeds arrived by ocean current, washed onto black sand. Others came in the droppings of seabirds that landed on bare rock. Mosses and lichens colonized the lava. Insects followed. Within decades, the island had a small but growing ecosystem, all without a single planted seed. Surtsey became a textbook of primary ecological succession, written in real time by the Atlantic itself. But just 30 kilometres to the northeast, on the island of High May, a different story was unfolding. In January 1973, a volcanic fissure opened on the edge of the town. Lava began advancing toward the harbour. Instead of abandoning the island, the people of High May fought back. They pumped millions of tons of seawater onto the advancing lava front. The operation took months, and it worked. The harbour survived, reshaped, but still functional. Today, the volcanic cone that nearly destroyed the town is a hiking trail above the rooftops. One island was left alone so nature could write its own story. Another was saved by human effort. Both sit in the same archipelago, close enough to lie within sight of each other across the water. Now consider a place in the highlands, roughly 100 kilometres east of Reykjavik. There is a bare patch of rock where a glacier used to stand. Its name was Okjökull. In 2014, scientists determined it had lost too much mass to qualify as a glacier. It was the first named Icelandic glacier to be declared dead. In 2019, a memorial plaque was placed on the site. It is titled A Letter to the Future. The plaque records the date and the atmospheric carbon dioxide level at the time. It acknowledges that Icelanders know what is happening to their land. The fact that Iceland chose to name, mourn and memorialise a glacier tells you something about the relationship this country has with its own landscape. This is a country where new land is still being created. Surtsey is proof. Reykjanes is proof. Fresh black lava fields that did not exist 5 years ago are visible here, clear proof of how quickly this landscape is changing. And at the same time, old landmarks are disappearing, glaciers are retreating, rivers are rerouting, coastlines are shifting. Iceland is moving in two directions at once, and the people who live here have to navigate both. Iceland is not a country that exists despite its geology, it is a country that exists because of it. The same rift that splits the ground created the island. The same volcanic heat that threatens roads warms homes. The same glaciers that define the landscape are retreating, leaving behind lagoons that visitors photograph without knowing they are evidence of loss. And offshore, new islands are still emerging from the ocean floor while scientists watch life arrive seed by seed and wing by wing. This is not a story about surviving the wild, but about what this landscape reveals when you move through it. It is a story about a society that learned to read the land closely enough to turn its forces into infrastructure, identity and daily routine. Around 400,000 people live on this island. They monitor their volcanoes, heat their homes from the ground, drive roads that close without warning. They protect moss that grows slower than memory on cold stone and wet ground, and they name their glaciers when those glaciers die. The ground beneath Iceland is not finished. It may never be, and that may be exactly the quality that made a country possible.